Hi everyone, I'm Nikhil and today I'm going to talk about my work which is controlling side effects in automated program repair. Bugs are quite prevalent in software and automated program repair tools help find minor bugs and this can speed up the development process. Yeah, in this work, we extend existing semantic program repair approaches to also handle patches with side effects or memory manipulating patches. The patch with side effect or a memory manipulating patch is a set of transformations which exchange the write to a different memory location. The first example is a memory manipulating patch because we write to a different memory location from P of A to G of A. The second example is also a memory manipulating patch because we make modifications to the address ampersand. Sorry? Oh yeah, is it audible? Yeah. Yeah. This is fine. Yeah. And the third example is a non-memory manipulating patch because the memory write happens in the same location. And memory manipulating patches are quite common because a preliminary estimation showed that around 82% of the bugs sampled from GitHub were fixed with memory manipulating patches. And it's hard to find memory manipulating patch because we have a vast increase in the search space and due to the increase in the search space, we also need to deal with under approximate specification, which is test suite, and due to this, we end up having to deal with overfitting. So it's like trying to find a needle in a haystack, but this haystack will also contain some pseudo needles, which is basically hairs masquerading as fake needles. And yeah, like memory manipulating patches change the existing L values and possible R values of statements. So yeah, let's briefly discuss what L values and R values are. R values are the values that are usually on the right side of an expression or there are if conditions, etc. And L values are the values that are on the left side of an assignment. And yes, in this work, since we extend semantic program repair approaches, let's briefly discuss these. Semantic program repair approaches that accept tests and a program to extract the patch specification. And this is usually done with concurrent execution. And a patch is synthesized using this patch specification. Consider this example. In this example, we can see the highlighted part. Yeah, we can see the highlighted part which denotes a buggy R value. Existing approaches replace this buggy R value with a symbol and then run concurrent execution. And with this, we end up with two paths, the path where R minus Y greater than 0 fails and the other path where R minus Y is less than equal 0. And using these two paths, we construct a specification, which is that there exists a patch P in the search space such that at least one of the paths satisfies with respect to the patch, and output is the expected output. And this approach can be easily extended to also handle L values by just enumerating every possible L value in a switch condition. And it's a pretty naive approach because usually there can be a large number of L values and there could be multiple L values for an expression. So this can rapidly explode our number of paths. One quick way to fix this issue is by adding KLEE open merge and KLEE close merge statements so that KLEE can automatically try to merge all the possible states generated in the switch condition. But there are issues with these. Because if the switch statement is extremely large, we'll have to deal with a large amount of merge overhead. And one better way which our tool tries to encode this issue is by directly encoding every possible assignment as a single state. And this is done in the following way. Consider this buggy program with a missing function call, and our tool tries to insert an abstract statement, which is an assignment of some abstract variables, And whenever the concolic execution hits the statement, we use the following, we add the following the following path condition, following constraint to the path condition. Here, x, y, z are the values of the variables before the execution of the abstract condition, and x prime, y prime, z prime are the values of the variables after the execution of the abstract statement. And sx, sy, sy are the selector variables. And whenever a selector is true, that means that the variable x prime gets assigned a new fresh symbol. And in the cases where the selector is false, the x prime retains its old value. And we restrict it to at most k selectors, because if we increase the number of selectors, we might end up having to assign some variables that shouldn't be assigned, and this could lead to overfitting. And yeah, these are the results of our approach Trident with respect to other baselines. And one is SQL, which is the switch statement technique with KLEE's open close word strategy. And yeah, Trident also has some additional heuristics that can reduce overfitting. We can observe that Trident can generate 6 patches and SQL could generate 3 patches in this data set. And GenProc could generate 0 of them because none of these fixes were existed anywhere else in the code base. And these are the results of the path counts for various tools, which is Trident, SQL, and SL. SL denotes the switch statement technique without any KLEE strategies. And we can see that Trident has a lower path count when compared with other tools. And one interesting thing is that in these bolded commits, we can observe that the bolded commits denote the cases where Trident could generate a patch and SL couldn't generate a patch. We can see that in these cases, the path count is extremely low for Trident when compared with the other tools. And with this, we can say that path explosion is a serious issue when dealing with in program repair. And this diagram, which for some reason looks like an amoeba, but it's a Venn diagram. And yeah, this diagram is a Venn diagram that shows the number of correct fixes for various tools. And yeah, Trident could generate 8 correct fixes, out of which 2 are exclusively generated by it. And one interesting thing is that Trident and Angelix are orthogonal approaches. And if you combine these approaches, we can end up with 12 correct fixes, which is large when compared with other tools. Yes, questions?